Gas tungsten arc welding. Gas tungsten arc welding is also known as tungsten inert gas welding. It is an arc welding process that uses a non-consumable tungsten electrode to produce the weld. The weld area is protected from atmospheric contamination by a shielding gas, usually an inert gas such as argon, and a filler metal is normally used, though some welds, known as autogenous welds, do not require it. A constant current welding power supply produces energy which is conducted across the arc through a column of highly ionized gas and metal vapors known as a plasma. Manual gas tungsten arc welding is often considered the most difficult of all the welding processes commonly used in industry. The reason is because the welder must maintain a short arc length, great care and skill to prevent contact between the electrode and the workpiece. Gas tungsten arc welding normally requires two hands, since most applications require that the welder manually feed a filler metal into the weld area with one hand while manipulating the welding torch in the other. However, some welds combining thin materials, known as autogenous or fusion welds, can be accomplished without filler metal. Most notable examples being edge, corner, and butt joints. To strike the welding arc, a high-frequency generator similar to a Tesla coil provides an electric spark. This spark is a conductive path for the welding current through the shielding gas and allows the arc to be initiated while the electrode and the workpiece are separated, typically about 1.5 to 3 millimeters, that is somewhere around 0.06 to 0.12 inches apart. Once the arc is struck, the welder moves the torch in a small circle to create a welding pool, the size of which depends on the size of the electrode and the amount of current. While maintaining a constant separation between the electrode and the workpiece, the operator then moves the torch back slightly and tilts it backward about 10 to 15 degrees from vertical. After that, filler metal is added manually to the front end of the weld pool as it is needed. Welders often develop a technique of rapidly alternating between moving the torch forward, that is, to advance the weld pool, and adding filler metal. The filler rod is withdrawn from the weld pool each time the electrode advances, but it is never removed from the gas shield to prevent oxidation of its surface and contamination of the weld. Filler rods composed of metals with low melting temperature, such as aluminium, require that the operator maintain some distance from the arc while staying inside the gas shield. If held too close to the arc, the filler rod can melt before it makes contact with the weld puddle. As the weld nears completion, the arc current is often gradually reduced to allow the weld crater to solidify and prevent the formation of crater cracks at the end of the weld.